Okay, GF Images and Productions present, in association with Derwent Training, presents Macaulay's Theorem, simply supported beams, which we did yesterday in class. Okay, this is our image, and what we've got to do is determine the Macaulay expression for the slope and deflection of the simple supported beam. What we have to do is you take the origin from the extreme left hand end and consider a section at the extreme right hand end of the beam from which we write down the Macaulay expression. Once written, and it's known as a ramp function, the rules apply. So next stage, we're trying to determine the slope and deflection. Step 1, find or take moments in the normal way. So m equals the right hand end x minus w1 times x minus a. Alright, you can read the function. This gives us the Macaulay expression for the whole beam, for the entire beam. We then move forward, so mass equals, or moments rather, equals the right hand end minus the force of 1 times x, which is basically the length minus a, minus the second force acting on the beam, or the point load acting on the beam, alright, by x, which is also the length, divided minus b. So we have to derive that, so we come down to moments divided by the flexural stiffness, and this gives us our formula. Okay, it is just as we did yesterday. It is just basically a plug and play scenario. You have the digits on the or the numbers rather from the problem. You just plug them into the formula. Step 2, what we have to then do is we integrate, and we integrate for the first time. We then integrate again, and then once we've done that, that allows us to set our boundary conditions. And what that means, so as you can see at the supports, we're trying to get the deflection at 0. So when x equals 0, y equals 0. Now when x equals a second moment of inertia, y is also equal to 0. What does that mean? That means that when x is 0 and y is 0, b is also 0. Now, so we found b. Now we've got to find a. A is found by a equals reactions at 1 times by the moment of inertia squared divided by 6 minus the force of 1, right, times the length minus a cubed, right, divided by 6 moment of inertia minus, and then it's the length minus b. Once you've done this, you can now solve for the slope and deflection along the entire beam.